Okay, so now let's cover the UI system within Unity. So first, let's right-click in the hierarchy, go to UI and Canvas. So everything in the UI for Unity lives on a canvas, which is a 2D sort of plane that contains your UI objects. So every canvas comes with 4 components. So it has a rect transform, which is 2D instead of the 3D transform that are on regular game objects, a canvas scaler, and a graphic raycaster. So this canvas component here has some important settings. So first it has a screen space render mode. So here we can do screen space overlay, screen space camera, or world space. So let me just create a image so I can show you what the different render modes look like. So if we go to our game view, right now our canvas is in overlay mode. This means no matter what, everything in our canvas will draw on top of our scene instead of being a part of the scene like other game objects. We can also do camera, and we have to set a render camera for this, so we select the main camera in the scene. And here, there's a variable called plane distance. So this plane distance is how far from the camera do we render the UI. So here, we can change the plane distance to be 10 to move it closer, or 1 to be even closer, or we can move it further away by doing something like 20, like 15. Oh yeah, so the cameras have a clipping plane, so things that are not within a certain distance of the camera will be clipped so that you don't see it. But yeah, so we can change the plane distance of this so that you see here, if we set the plane distance to 6, it will now, this canvas is now slightly further away from the camera than the ball. So the ball will render on top of our canvas, but the canvas still renders on top of anything that's further away, like this floor. Finally, there's the world space. And the world space render mode means that this, unlike the other 2 modes, the canvas lives in the scene like any other game object. So let me just reset this transform. Oh, maybe I should do that. Okay, yeah. But let's move it to here. So now we can, for example, move it left or right in the scene. Yes, we can rotate it. So now if we go to the scene view, you see this canvas is now like part of the scene, and it's rotated so it looks like it's on this wall here. So this is good for things that you want to show up in your game, like other game objects. Okay, so let's set this back to overlay because that's the default for UI, so that it always shows on top of your screen, so you can always see the canvas. And we also see there's a sort order variable. So if you have multiple canvases, canvases with a larger number in your sort order are drawn later and therefore will appear on top of other canvases. Okay, to demonstrate the canvas scaler, let me change the size of the image. So you see this image here. So, okay, actually, let me change it back. So when you have a constant pixel size for the canvas scaler, no matter how you change your screen size or resolution, this square will always have the same number of pixels in it. There's also a constant physical size so that you can guarantee that for example, buttons will always be pressable instead of shrinking or growing based on the screen size and number of pixels on that screen. And there's also scale with screen size. So here we need to set a reference resolution. So I'll just set it to be 1920 by 180 because that's a good default size for the full HD resolution. And here we can change our size of this image to cover the whole screen. So now let me show you what these screen match modes mean. So when we have match, so here if we set our screen resolution to 1920 by 180, we can see that our image will now scale based on the size of the image. So if we can change this to match, oh actually, let me change. Okay, so yeah, if we do free aspect, we can drag this height to see that right now it's matching height, so it always expands to the maximum height. Alternatively, we could do match the width, so it always expands to the maximum width, or we can do something in between, like 0.5, and we'll try to match both of these. Alternatively, you can go using the expand. So this expand will always try to expand your canvas from the center to fill as much of the screen as possible without getting cut off by the edge of the screen, as you can see here. Or we can use the shrink mode, which will so as you can see, no matter what we drag, it always covers the full screen. So what's happening here is that the canvas is shrinking around your screen and then down to the minimum size where it always covers the entire screen. Okay, so for our UI, this rollerball game is going to be fairly simple. So we can just stick with a constant pixel size and overlay. And let me just delete this image so it doesn't cover the entire screen. Okay, so for our UI, we want three things. We need a score counter in the upper left corner, a timer counter in the upper right hand corner, and as well as a game over screen that will display when you run out of time. So first, let's go to our canvas, right click on the canvas, and create a UI image. So this will automatically create an image that is a child of the canvas. And please note that UI objects should always be a child of some canvas. And then right click this image so that in the hierarchy so that we can create a UI text, and it has to be the Text Mesh Pro version. So Unity also has a older text component which you should not use because the Text Mesh Pro is basically superior in every way, and the older text version is just for backwards compatibility essentially. So here, let's just change the text to be, for example, score and 0. We can change the color so that it will show up, so you can see it on this white background image. And next, so we want this background image to sort of wrap around this text, so we can use a layout group. So there's multiple types of layout groups. For this purpose, both vertical and horizontal layout groups work, but they're basically the same thing, except vertical layout groups allow you to have these stack things vertically, and horizontal layout groups let you stack things horizontally. So when you add a vertical layout group component, you should check the control child size for both width and height to make sure that this text will always fall within the bounds of this image. So as you can see, the text is within this image. And then we can add a content size fitter component and set to preferred size for both horizontal and vertical fit. So now our image background will change its size to the minimum, this minimum size that wraps around the text. And you can also add a little bit of padding if you'd like. on the various sides of the box so that the text isn't touching the edge of the box exactly. Okay, so now that we have this nice score box, we need to put it in the upper left corner. So we can do this by changing this. So we want to put the box in the upper left corner. So we refer to this top left anchor. So this means Unity will, this position X and position Y is how far to the right of the upper left hand corner is our box and how far down from the upper left corner is our box. So let's just set that to 0. And you see now the box is in the corner, but it's being cut off. So 3/4 of this box is not visible. So what we need to do is to change this pivot. So we change the pivot to 0 and 1, and also set this position X and position Y to 0 again. So what the pivot, this pivot means is when it calculates the distance from this upper left-hand corner of the screen, what part of our image should it calculate to? So before it was 0.5 and 0.5, which means it was calculating the distance to the center point of our image. So now that we've set it to x0, y1, it's now calculating the distance to the upper left-hand corner of the image. So now the upper left-hand corner of the image and the screen coincide. So even if I drag the screen size and change it, the text will always stay in the upper left-hand corner. So we can just copy and paste this to create our timer text and background. So here we want this to be in the upper right hand corner, so we do something very similar where we select the upper right hand corner. We change the pivot to the upper right hand corner of the image, so by doing 1 for x, so this is like a fractional of the image, and then we set x to 0, and now we just need to change the text so it's time and say like 0.0 seconds left. Okay. Lastly, we need to create a game over image or screen that should show up when our game is over. So let's just create a UI image, and we want this to be the game over screen. Let's give it a different color, maybe a darker color, because game over is a bad thing. And for this one, since we just want to cover the entire screen, we can set it to, instead of one of these 9 anchor presets, we can select the stretch in both directions preset. So now this will calculate, this rect transform instead will have a left, top, right, and bottom numbers indicating how far from the edge of the screen is each of these edges of our image. So for example, we are 412 units from the left hand side of the screen. So let's just set that to 0 for all of these. So now our image covers the entire screen. And then of course we need to add some more text to show that it's game over. And let's move this up a little bit. Create another UI text so we can have this be like our final score. Let's say 0 for now. Oh, we can also, since you can see that this text component isn't wide enough to contain our full text, we can add a content size fitter to this as well and set it to the preferred size so that the text will fit inside of the box. And finally, let's just add a UI button and make sure it's also the Text Mesh Pro version. And let's move it down a little bit. And now we can have this button say restart. So now later when we link this button up to a function that will reload the scene, we can restart the game. Okay, and then since we don't want this game over screen to show up until the game is over, we can just click this little button here to disable it until we need it. Now I'll hand it off to my fellow officers to discuss how to implement the score and timer functionality as well as switching scenes.
Okay, so one thing I did is to organize the score, timer, and game over UI elements into a prefab just by dragging it into the project window and calling it UI. And so one thing we need to do is we need to organize and actually implement the score and timer mechanics. So the first thing I'm going to do is I created a empty game object calling this game controller. And inside this game object, there are going to be the scripts for the score and timer as well as the game over screen. So let's work with the timer first. I'm going to add a component and name this timer controller. It's going to be a new script. Okay, and so in this script, I'm going to need a couple variables. First, I need the time to count down from. So this is going to be a serialized field, so I can change in the editor. It's going to be countdown time. And then another thing I need is the start time, which is going to be a public float. And this is essentially going to be when we start counting down. I'll also need a UI component, a reference to the UI component, so the text for the timer. And this is going to be a serialized field, private text mesh pro. This isn't recognized right now, so I have to include a reference to the library we're using, which is text mesh pro. And then in our start function, we'll have a couple things. Okay, and so in this start component, I set the time scale to 1. Essentially, when the game stops in the game over screen, I'm going to set the time scale to 0. And so when the game restarts, when the timer starts, the game should unpause itself, so I set time scale to 1. We assign our start time to time.time, which is the current time during this frame. And then we store that in a private float value. And this last statement here is a assert statement, essentially checking if the reference to the timer element of the UI is not null. Otherwise, it's going to print out a message in the console that we're missing a reference to it. Next, we're going to define our void update function. Okay, and so in this update function, I calculate the time elapsed by taking the current time when the update function is called minus the start time. And then we have the time remaining value, which is calculated by taking the countdown time, which is the time that we're counting down from, minus the time elapsed. And then we want to check if the time elapsed is less than the countdown time, because it could go negative. If so, we just set it back to 0, and we destroy the timer. Lastly, we update the timer in the UI element right here using a format string. Okay, so let's set the countdown time to 10 seconds and reference the count text, which is going to be our timer text, and play. And as you see, it counts from 10 seconds. So now we want to implement the score. What we're going to do is add a new script called score controller, add this to the game controller object. In this script, we're going to add using text mesh pro. And it'll contain the following variables. First is a public static int score, which will keep track of our current score. It's a static variable, which means that it doesn't belong to an object. We don't need an object to be instantiated to reference this. We can simply reference the class name, which I'll demonstrate later when we implement pickups. We'll also need a reference to the score text because the pickup will reference this later. And essentially in this update function, it's going to be really simple. We're just going to set the score text to the updated score. Okay, and don't forget to assign the score text in the editor. Nice. Okay, now we need to actually implement pickups. So essentially when the ball rolls into a pickup, it will give a certain score amount and it should update in the UI. So let's create that right now. What I'm going to do is I'm just going to create a cube which will represent our pickup. All right, here's the cube. I'm going to reset its position. And I'm also going to resize it so it's not so large. Let's make it 0.2. Okay, and it has a box collider. I'm going to add a script. I'm going to call this pickup. Okay, this script will only have one function, and that's going to be a private void on trigger enter. It's going to take a collider. I'm going to check the tag of the object that it collides with. I want to check if it's the player. If the player collides with it, I want to access the score from the score controller, which was a public static variable. And I want to increment its count by 1, so increase the score by 1. And then after that, I want to destroy the pickup so it disappears and the player can no longer pick it up. Okay, I'll save this. And so one thing I need to do is also I have to mark this as a trigger. And so if this is enabled, this will be used for triggering events. And then the physics engine will ignore it. So if I press play here, as you see, the object disappears and the score is updated now. Okay, so let's say we want to actually add a little animation to our cube here. Let's have it spin. So the first thing we need to do is we have to add a animator component. Let's create an animator controller. Name this pickup. If we double click here, we'll have a new window called the animator window. And as you see here, it has any state, entry, and exit. And what this is sort of a state machine, which represents the current animation states that the ball or object is currently in. There'll be arrows pointing to different animation states, and you can use this to manage the animation states and transition between them based off parameters. For now, there are no animation clips, so we'll need to add one. To do that, let's go back to our scene view, click on the object. Well, let's first actually assign this this animation controller. And let's create an animation clip. So to do that, we can go to Window, Animation, click on Animation. This brings up the animation window. We want to animate this object, so let's create an animation clip and name this spin. Okay, so when you click on this, it'll bring up a new window, a timeline. So the way you read this, essentially the timeline, the first number represents the second in the animation starting at 0, and the second two numbers represent the frame. And this is dependent on the number of samples that you're recording. So for example, I have this set to 60, so per each cycle there's 60 frames per second of an animation, and I can change this to like 30 for example, and the timeline will reflect that accordingly. And so one thing you can do is we can click this record button. When we click the record button and we move the timeline, for example, and then we also add a property, we have to add this as rotation right here. So we're recording rotation. If we move this in the scene editor, notice how the rotation is reflected on the timeline. It's recorded, and as you see, these values here are highlighted in red, indicating that they're changing. And if we press spacebar, we can actually play the animation, and we notice how these keyframes record the properties or rotation of the object at a certain frame in the animation. So right here, it's set to 0, 0. Here we have certain values for the rotation, and here it's set to 0, 0 again. And in between these keyframes, there's interpolation of the values. So essentially, it wants to get the y component of the rotation starts at 0 and wants to get to this value by this frame in the animation, which is how keyframings work. So let's say we want this to spin. One thing that we can do is, let's add rotation again. Let's set this at 0, 0. Let's set this at about halfway through the animation. Let's have it set to 180 degrees. Let's set this to 360 degrees at the end. And then let's press play and see what happens. And so we press play, but it seems that there's a slight pause at the end of the animation as it resets. And to fix this, we can go into curves right here, and this will give us another view of essentially the animation. And so the reason why it's not exactly smooth is that there's a slight bend in the animation curve. We don't want this bend. It results in the hiccup movement, so we want to try to make this linear. So we can do that by doing this, setting this manually and try to make this as straight as possible. We can click on the line here and it generates, or this will represent our keyframe. We can also drag up and down to modify the tangent of the line. Let's right click on it, both tangents, let's set this to linear. Let's also set all the keyframes to linear. And last, right here, we'll set this to linear. And as you see, the animation looks a lot more seamless right now. So you can play around with this, try to make the animation as smooth as you want. You can stretch it out over multiple seconds if you want the rotation to be slower. But for now, I'll keep it like this. I'll stop recording, and this will be our animation for the pickup. And so we can click on the animator tab, and we see now that there is a arrow, a transition from the entry state to the animation clip that we've selected. And what will happen is that on startup, when we press play, the state machine starts from entry and goes to our animation clip. And currently, it's repeating this animation clip because if we go to the animation clip right here, it's set to loop time. And so if I click play, the pickup now works and it updates the score. And so the last thing I want to implement is the actual game over screen. Right now, the object is set to inactive, but we want to activate it after the timer runs out. And so we're going to go to game controller. Let's add a new script. Let's call this game over. This script will reference TextMesh Pro, as well as Unity Engine.scene management. What we want to do is we want to have the restart button essentially load up a scene, which is why we're using this library. It's going to take a couple of variables, so we're going to have the reference to the score text. We're also going to have a reference to the game object, which is the background, so we can activate it. We're going to have a function called display final score. It's going to take a integer score. It's going to be public. What we want to do is we want to set the background to active. So it displays. We want to update the score text to be the score that the player has. So this will be a format string. Then we want to reset the score controller to 0. And then we want to set the timescale to 0 as well. So essentially we want to pause the game so the player can no longer move. Okay, then afterwards we want to actually code the restart button, which is going to just call scene manager and then load scene, and it's going to load our first scene again, which will be the name of the scene that we want to load, which is level 1 basics. Okay, and so now that we have this set, let's see if it compiles. Let's add our references. So the score text, not on the score background, but on the game over background. Let's update this controller. And then we'll take a reference to the game object, which is our background. And then now we want to go back to our timer controller script. And we want to add a reference to our component that keeps track of the game over. So that's going to be private game over. And what we want to do is when the time expires, we want to call the function display final score, and then we want to pass in the static score value. And then one thing I need to add is on the start function, we're going to look for the game over type right here, game over object. So we can do this, game over. Essentially what this will do is this will look for an object of type game over, and since there's only one object of this type, it will always return what we expect it to. And then let's set the timer to just 3 seconds, so it's quicker. 1. Awesome. So now we have the game over screen with our score. And if we click restart, it doesn't work. Why? Because we have to actually configure a button. So if we go over to here, on click, essentially what this will do is we can run a specific function belonging to a game object. In this case, we want to call restart. So let's pass in the game controller. Let's go, it belongs to the game over. And then we click restart here. So whenever the button is clicked, it'll call the restart function, and we expect the game to restart. So let's try that again. Click restart, and the game restarts.
Okay, now that we've inputted some UI as well as some pickups, let's go ahead and move on to another important concept in Unity, scene transitions. So to move on to other levels or stages in a game, it's important to know how to switch between scenes in Unity. And to do this, we'll create a new scene and name it something like level 2. So go to right click in your scenes folder, create scene, and then level 2. So now we have our new scene. It comes with a default main camera and directional light, but if we don't want to if we want to save ourselves some work in creating a new level, we can just copy everything from level 1 here and paste it onto our new level 2. So if you shift click all these elements and then right click copy, and then go to your level 2, go ahead and delete these items and just paste, you get the exact same copy of your level 1 in your new scene. But we don't exactly want the exact same thing in our level 2. We want some way to distinguish between the levels. So let's go to our materials folder, right click, create material. And let's go ahead and make this something like green. So it's like really easy to tell that we're in a new level. And then if we go to our second scene, while we're already in here, we can drag it onto our walls right here in our scene window. Okay, now we'll definitely be able to tell that we're in level 2 once we switch there. Now to actually switch between scenes, we're gonna need a trigger or some kind of event to tell our game, hey, let's switch over to the scene. So if we head over to our first scene, we can select this platform here. Let's make it so that landing on this platform triggers our entrance to the second scene. So if we go over here on this right side in the inspector to under the box collider, we can press is trigger, and this will make landing on this platform trigger an event, which we can later on manipulate through scripting. And then if we head over to our scripts folder, right click, create C# script, we can start adding our new script to move to the next scene. So let's call the script something like to level 2. And let's open it up. Okay. Now we don't exactly need these methods in Unity since we're only worrying about a trigger event. So if we call the function void on trigger enter collider, we can get the trigger when the collider is touched. And to import scene management characteristics in Unity, we're gonna have to import. We're gonna have to type in using Unity engine dot scene management, and then under here to actually load our new scene. Once the trigger is set off, we have to type scene manager load scene, then the name of our scene, which is level 2. Okay, so now we have our script all ready. We can hop into back into our scene and then press on the platform and drag our new script into here. Okay, now I guess we can go ahead and try it out. Boom, we're in our next scene. Let me go ahead and make this window a little bigger. So as you can probably tell, this second scene is like extremely dark for some reason. And that's because each scene in Unity needs their own lighting. So every like new scene you make and create and switch to in Unity within the game is gonna have some weird lighting. So in order to fix this, you have to enter window, rendering, lighting, and then if you press generate lighting down here, it will generate some new lighting fixtures. Wait, let me go ahead and do that again. The second scene, window, rendering, lighting, and then generate lighting. Okay, now we've got some lighting in our second level, and we can go ahead and try that again. I was starting from level 1. Okay, and everything's nice and bright again. But we don't really want our game to end right here, right? It's just landing on a platform and just heading and just doing nothing in the second level. So we can go to our second level and we can make the platform in this level send us back to level 1. So if we go here, press is trigger, we can go ahead and do the exact same thing we did last time. Create a new script. Let's call this to level 1. And then type in the exact same thing we did earlier. So using Unity engine scene management. And then down here, void on trigger enter, collider. and then scene management, scene manager, load scene, or let me get the level name. In this case, it's called level 1 basics. So I'll name it level 1 basics. Yours might be different, but this is just the one I'm working with right now. You can go ahead and save this. Head back to our first scene or our second scene and drag this new script onto the platform. So we can send this right here. And let's go ahead and play the game from level 1. Sorry about this. Okay, now we're just testing this out now. And boom, we're back in level 1. So we're just in a constant loop of just jumping onto platforms. So this is the state of the game that we've made. It's obviously not the most fun game to play, but we've definitely learned a lot during this tutorial series, and I hope you have as well. Right now, this is basically all that we're doing, and this should be the final stage of your game. If you have any questions, of course, message us on Discord, or you can message any of the officers or message in the help channel. And this should be about it. So thank you all for watching, and I hope you all have a nice day.